Hi guys, welcome back. Today we consider absolute minimums and maximums. We start off with the extreme value theorem. The extreme value theorem says that suppose we have a continuous function f of xy in some closed bounded set D in the Euclidean R2 space, then f of xy has an absolute maximum and an absolute minimum in the given region D. To find the absolute extrema, that's the absolute minimum and the absolute maximum of a given function in the given region, we use the following steps. Step 1, we sketch the given region. Step 2, we find all the critical points of the function in the region. Then we determine the function value. Step 3 is we find all the extreme values on the boundary of the given region. Then the last step is to compare the function values from step 2 and step 3. Then we pick the maximum and the minimum of those function values and the points at which those function values occurred. With this in mind, let's try our first example. With example 1, we have to find the absolute minimum and the absolute maximum of the given function f of xy in the rectangle given by these two inequalities. Sketching the given inequalities give this rectangle. So now we should first find the extreme values in the interior of this rectangle. Then after that, we now find the extreme values on the boundaries. So we are going to pick the boundary one after the other. So we first solve for the right boundary, the left, the top and the bottom boundary. Let's now solve for the interior critical points. We now compute the critical points of the interior region. So here we just have to differentiate the given function partially with respect to x and with respect to y. Then we set our answer to be equal to 0. So finding the partial derivative of f with respect to x will be given as 2x minus 4xy. And that of partial of f with respect to y will be given as 8y minus 2x squared. So we now set the partial derivatives to 0 so that we can find the critical points. So we are going to have 2x minus 4xy is equal to 0. Then we call this guy equation 1. Then 8y minus 2x squared is equal to 0. Then we call this guy equation 2. So from equation 1, we can factorize 2x out, which is going to give us 2x out 1 minus 2y is equal to 0. So that's 2x is equal to 0, or 1 minus 2y is equal to 0. Solving this gives x is equal to 0 or 2y is equal to 1. So that's y is equal to 1/2. So we now have a value for x and a value for y. So now here we are going to substitute each of these values into equation 2. So that's when x is equal to 0, what will be equation 2, and when y is equal to 1/2, what will be equation 2. For x is equal to 0, equation 2 will now become 8y minus 2 times 0 squared is equal to 0. Thus 8y is equal to 0, implying that y is equal to 0. So now, thus we have the points 0, 0. Thus when x is 0, y is also 0. Now we do same for when y is equal to 1/2. When y is equal to 1/2, equation 2 will now become 8 multiplying 1/2 minus 2x squared is equal to 0. So thus we're going to have 4 is equal to 2x squared. And thus x squared is equal to 2, implying that x is equal to plus or minus the square root of 2. Now let's verify if these x values are in the given range. So we were told that x lies between -1 and 1. This implies that these two values are not in the given range, and so we are going to discard these two values. Thus the only point for the interior region is 0, 0. So we now compute the function value of f at 0, 0. So thus we are going to have 0 squared plus 4 0 squared minus 2 0 squared multiplying 0 plus 4. So that's 4. So for the point 0, 0, we have our function value to be 4. So that's for the interior points. So we now move on to solve for the critical points on the boundary of the given rectangle. Let's start with the right boundary. So when x is equal to 1, the y values lie in between -1 and 1. So we are going to have our function f of xy to be given as x squared plus 4y squared minus 2x squared y plus 4. Now here we are saying that x is equal to 1, so we are going to have f of 1y is equal to 1 squared plus 4y squared minus 2 1 squared multiplying y plus 4, which is going to give us 4y squared minus 2y plus 5. We now differentiate this guy to find the critical points on this boundary x is equal to 1. So we are going to have d dy of f of 1 y will be given as 8y minus 2. Then we now set this guy to be equal to 0 because we are finding the critical points. So we are going to have 8y minus 2 is equal to 0. And so we have 8y is equal to 2. Thus y is equal to 1 over 4. So thus on the boundary x is equal to 1, we have our critical points to be 1 over 4. By the extreme value theorem, the maximum and the minimum on the boundary x is equal to 1 may lie on the boundary or at the critical points. So we need to check for each of these. So you now have the points 1 over 4, that's for the critical points. Then at the endpoints we have y to be -1 and x to be 1, and y is equal to 1 and x is equal to 1. So you have the points 1 minus 1, then 1 1. So we now compute the function values of these guys. So we now compute the function values of these points. So we are going to have f of 1 4 will be given as 1 squared plus 4 1 over 4 squared minus 2 1 squared 1 over 4 plus 4, and this will give us 19 on 4, which is the same as 4.75. So then we do for the rest of these points. So that will be f of 1 1, and that's 1 squared plus 4 1 squared minus 2 1 squared multiplying 1 plus 4, and that's going to be 7. Then lastly, for f of 1 minus 1, we are going to have 1 squared plus 4 minus 1 squared minus 2 1 squared minus 1 plus 4 will give us 11. Do same for the left boundary. So when x is equal to -1, the y values will lie in between 1 and -1. So we are going to substitute in x is equal to -1 into a given function. So we are going to have f of -1y is equal to -1 squared plus 4y squared minus 2 minus 1 squared y plus 4. So that's 1 plus 4y squared minus 2y plus 4. And this will give us 4y squared minus 2y plus 5. So this function is just the same as the first one that we got. So the critical point will just be the same. So let's differentiate this guy with respect to y. That's going to give us 8y minus 2. Then we set our answer to be equal to 0 to find the critical point. So 8y minus 2 is equal to 0, and that's y is equal to 1 over 4. So this is just the same as the first one that we got. That's on the boundary x is equal to -1. We have the critical points to be 1 over 4. And the y values lie in between -1 and 1. So we are going to have the points -1, 1 over 4, then x is -1, y is -1 on the end of the boundary, and x is -1 and y is 1. We now compute the function values at these points. So f of -1, 1 over 4 will be giving us, that's x is now -1 and y is 1 over 4. So that's -1 squared plus 4, 1 over 4 squared minus 2 minus 1 squared 1 over 4 plus 4. And this will give us 4.75. So similarly, for -1 minus 1, we are going to have -1 squared plus 4 minus 1 squared minus 2 minus 1 squared minus 1 plus 4. And this is going to give us 11. So we do same for the last one, f of -1, 1. So that will be -1 squared plus 4, 1 squared minus 2 minus 1 squared times -1 plus 4. And this is going to give us 7. So we do same for the top boundary and the bottom boundary. So that we first solve for the top boundary, that's y is equal to 1. So when y is equal to 1, x will lie in between -1 and 1. So that's our function is going to be f of x. Y is now 1. So our function is going to be f of x. Y is now 1. So we are going to have x squared plus 4 minus 2x squared plus 4. So that's just minus x squared plus 8. So we now differentiate this guy with respect to x. So differentiating f of x1 with respect to x, we are going to have minus 2x. We set this guy to be equal to 0 in order to find our critical point. So that's x is equal to 0. Thus, on the boundary y is equal to 1, we have our critical point to be equal to 0. We have the points 0, 1, minus 1, 1, and 1, 1. So the function values will be giving us f of 0, 1 is equal to 8, f of -1, 1 is equal to 7, and f of 1, 1 is equal to 7. So we now solve for that of the lower boundary. So here y is equal to -1. So when y is equal to -1, x lies in between -1 and 1. So that's when y is equal to minus 1, our function will now become f of x minus 1 is equal to x squared plus 4 minus 1 squared minus 2x squared minus 1 plus 4. That's going to give us x squared plus 4 plus 2x squared plus 4. Simplifying this gives 3x squared plus 8. So we now differentiate this guy to find the critical points. So d dx of f of x minus 1 will be giving us 6x. Then we set this guy to be equal to 0. So 6x is equal to 0, implying that x is equal to 0. Thus, on the line y is equal to minus 1, we have our critical points to be 0, and the x values lie in between minus 1 and 1. Thus, we have the points 0, minus 1, minus 1, minus 1, and 1, minus 1. So we now compute the functional values of these guys. So you're going to have f of 0 minus 1 is equal to 8. F of minus 1 minus 1 is equal to 11. And f of 1 minus 1 is equal to 11. Last step is to select the maximum and the minimum function values. So here we can see that the minimum function value is 4, and it occurs at the point 0, 0, and the maximum function value is 11, and it occurs at 2 points. Thus 1 and minus 1 and minus 1 minus 1. Hence our conclusion will be the absolute minimum occurs at the points 0, 0, and the absolute maximum occur at the points 1, minus 1 and minus 1 minus 1. Thank you for watching. See you in the next video. Bye.